Alright guys, we are going to look at the last lesson of the year, Chapter 8, Lesson 3, Volume of Spheres. Textbook definition of a sphere is a set of all points in space that are a given distance, known as the radius, from a given point, known as the center. So really, you're talking about a three-dimensional circle, a basketball, a soccer ball. My questions to you today are, how can we use the formula for a cone, which we talked about in Lesson 2, to find the volume of a sphere? So in Lesson 2, we talked about how we could use the formula for the volume of a cylinder to figure out the volume of a cone. Now I'm asking you how we can use the formula for a cone, for volume of a cone, to figure out the formula for volume of a sphere. Just like last time, I want you to think about how many cones with the same radius and height would fit into a corresponding sphere. And by the way, it's important to note that spheres don't technically have height. They have diameter, which goes the distance all the way across. Diameter is also known as 2 times the radius. More on that in a minute. So at any rate, I want you to think about how many cones would fit into a corresponding sphere. Normally I would have you guys actually fill up a cone with water and dump it into a sphere to figure it out, but we can't do that. So just like last time, I'm going to show you guys a quick video where essentially they are doing the same thing. It's important to note here that he uses a couple of geometric solids that are not really part of the equation. He's using a pyramid to pour out of, because it has a nice corner and it's easier to pour out of. So that just don't be confused by the fact that he kind of switches back and forth. Okay, so here we go with filling up the cone. And it's hard to pour out of this cone, so he transfers it to a pyramid that has a nice corner that he can pour out of. Okay, so I know it's kind of hard to see, but it looks like it's about halfway full. So he's going to do it again, see if he can fit another one in there. Again, he's just going to transfer it to the pyramid so he can pour it more easily. And there you have it. 2 is the answer. So if you guessed 2, you are correct. If maybe you thought 3 because of last time, turns out 3 isn't going to work. So this time 2 cones can fit into a corresponding sphere. The volume of 2 cones can fit into the volume of a corresponding sphere. Okay, so let me walk you through basically what this means. So this looks pretty complicated. It kind of is. This is really just an attempt for me to try to explain to you why this formula works, okay? So here we go. Here's what we just watched in the video. We figured out, or we saw that 2 cones were equivalent to 1 corresponding sphere, okay? So down below I have the formula of a cone plus the formula of a cone. Remember that the formula is the area of the base, pi r squared, times the height divided by 3, because 3 of these fit into a corresponding cylinder. And this is the formula for volume of a cylinder. Okay, so we're adding the 2 together. I mentioned this to you guys a minute ago. Notice that there's no such thing as height in a sphere. Okay, height is really the same as diameter. Diameter is really the same thing as 2 times the radius. So all I did here is I rewrote it. Instead of calling it height, I'm calling it 2 times the radius. Okay, so let's see, I'm going to get rid of that for right now. We'll come back to that. Here is basically the same formula, except for all I did is I swapped out, instead of height, I'm calling it 2 times the radius. Okay, so pi r squared times 2 times the radius divided by 3. There are 2 of them that fit into a sphere, so I have to add the 2 together. Okay, so here's what happens. I'm going to actually add these 2 together. So I'm going to bring the 2, following mathematical convention, I'm going to bring the coefficient to the front. So I'm going to bring each of the 2's to the very front. And so now I have 2 pi times radius squared times radius divided by 3 plus 2 pi times radius squared times radius divided by 3. Okay, so we're going to go ahead and we're going to add what we can. Up top, if I add 2 and 2, I get 4. Recall from our days in August, the beginning of the school year, when we were multiplying exponents with the same base. So I'm going to expand this. R squared times R. R squared times R. Well, if it doesn't have an exponent, what can you assume is there? A 1. When you're adding exponents with the same base, what are you really doing? When you're multiplying exponents with the same base, you are really adding the exponents. So R squared plus 1, R cubed. Okay, so 2 plus 2 is 4 times pi. R squared times R is R cubed. It's still all over 3. So this is the formula for volume of a sphere. You can also see it written as 4/3. Give myself a little more space. 4/3 times pi R cubed. You'll see it written either way. This is the one that I'm going to use. Okay, so that was complicated. Again, it's just I'm trying to explain to you how and why this works. So if you're not quite clear on it, maybe rewind it, watch it a couple more times, and see if it makes sense. At the end of the day, really all we're going to do is we're going to plug in the radius. They're going to give us a word problem. They're going to give us a figure. Like, let's take a look at example 1. Okay, they're giving us a radius of 6. We're plugging that in for R. We're cubing it. We're multiplying it by pi, multiplying it by 4, dividing by 3. Okay? So I'm actually going to have you guys do, let's try A. First thing to notice about A is they are giving you diameter. Just like in 8-2 and just like in 8-3, you need radius, so take that diameter and cut it in half. Divide by 2. So half of 22 means our radius is 11. Okay? So volume is equal to 4 pi times 11 cubed divided by 3. So one of the most common mistakes in Chapter 8, Lesson 3 is people are so used to squaring radius, they forget that it's not squaring, it's cubing. You're cubing the radius. So just to give you a little reminder, you're going to use to the power of button and then a 3. So let me model this for you guys in the calculator. Okay, so clear that out. 4, you can hit multiply if you want, or you can just hit pi. If your calculator doesn't have a pi button, you're going to use 3.14. 4 pi, and again, you can hit multiply if you want, or you can just hit 11 to the power of 3, and then all this gets divided by 3 at the bottom, at the end. Okay, so I got 5,575.3. 5,000. Oops. Volume is approximately 5,575 point. Remember that it's rounding to the nearest tenth. So this 7 in the hundreds is going to round the 2 in the tenths column up to a 3. I'm going to make sure to include my unit of measurement is centimeters. This is a 3-dimensional object, so cubic centimeters or centimeters cubed. Okay, there's our approximate answer. Okay, so let's move on. And recall, I mentioned to you guys before, you can also write your answer is a product of pi. I'm not exactly sure what you're going to see in the back. I think, yeah, they're approximating. So I'm just going to go ahead and stick with what I've done here. Okay, let's move on. Take a look at, you know, just keep your eye out for word problems if they give you diameter. Make sure you're cutting that in half. Okay. So there's going to be a problem kind of similar to this in the homework. A volleyball has a diameter of 10 inches. You're going to cut that in half. You're going to plug in 5 for the radius. A pump can inflate the ball at a rate of 325 cubic inches per minute. So basically what's going to happen essentially is you're going to take your volume and you're going to divide it by 325. Okay, so I'll actually kind of walk you guys through the homework problem that is that you're going to see. Okay, so here's actually a second vocab word, and it is hemisphere. So let's see here. A circle separates a sphere into two congruent halves, each called a hemisphere. So basically, it's half of a sphere. Okay, so let's take a look at one of these. Maybe let's actually try one. So let's go ahead and do E. This line goes all the way across through the center. So that means its diameter, I have to cut it in half, right? So half of 2 means my radius is 1. Okay. I'm definitely going to need a little bit of space on this one. And I can tell you in the homework which ones are going to look like this. Hemispheres, 8 and 9 are hemispheres. Number 8 and number 9. All right, so volume is equal to 4 pi r, in this case is a 1, cubed, divided by 3. Guess what? It's a hemisphere. So divided by 3, divided by 2. You have to cut it in half at the very end. Let's see, I'm going to move this down a little bit. Let's see how the textbook shows it. They're multiplying by 1/2. That's, to me, even a little more complicated. So here's your formula. 4 thirds pi r cubed, otherwise known as 4 pi r cubed divided by 3, times 1/2. If that works for you, go ahead. I prefer to just show it as division. Multiplying by 1/2 is the same as dividing by 2. Okay, so I think it's probably going to be important to show this on the calculator. There's my radius. Let's see what happens. Okie dokie. I'm going to clear it out. Okay. So let's see here. 4 pi 1 to the power of 3, which guess what is just 1. 1 times 1 times 1 is still 1, right? All of this, let's see what happens. Divided by 3, so this would be the whole hemisphere. I'm sorry, this would be the whole sphere. Now divided by 2, that's the hemisphere. That's half of a sphere. And we land on, again, they're asking you to round to the nearest tenth, so the 9 in the 100th spot is going to round this 0 to a 1. So we're going to land on volume is approximately 2.1 cubic centimeters. And checking the back of the book, that checks out. Okay? So essentially, you're just going to hit that division button twice. Okay? Divided by 3, cut it in half, divided by 2. Okay. Let's see what else we have here. We do have some composite solids. Do they have a... I might not have one in here. That's okay. So let's just jump into the homework and talk about some of these. 1 through 4, pretty straightforward. 1 and 3, they're giving you diameter, so make sure you're cutting it in half. Go ahead and divide that diameter in half to get the radius. Otherwise, 1 through 4 should be pretty doable. And then just, here are the key commands for number 1. 4 pi 7.2 to the power of 3 divided by 3. Okay, let's move on. 5 should be very doable. It's a word problem, but they're giving you the radius. So you're plugging it into the formula, easy peasy. 6, again, they're giving you radius. So 5 and 6 are very similar. Plug in the radius into the formula and you're all set. Okay, 7. I mentioned to you earlier, I believe this one corresponds, see example 3. Oh, it tells you that right here. See example 3. Okay, so it tells you that a spherical ball has a diameter of 8, which means it has a radius of 4. It has a slow leak and air is escaping at a rate of 2.5 cubic inches per second. How long will it take for the ball to completely deflate? Round to the nearest tenth. All right, so you're going to basically figure out what the volume is, and you're going to divide that by 2.5 cubic inches per second. That's going to tell you how long. All right, so this is this means division. Okay, so go ahead and plug in the volume, divide it by 2.5, and that's going to give you how long it's going to take. Okay, moving on. 8 and 9, hemispheres. 8's giving you the radius. 9 is giving you the diameter. Cut it in half to get the radius. Go ahead and plug it in. So you're going to say, 4 pi times 0.9 cubed divided by 3 divided by 2. Okay, this is just like example E. We just did this, example E. See example E. Okay. 10 and 11. Let's do one of these. Let's do 10. So they are asking you, my directions got cut off, but it says find the radius. So they're giving you volume. I'm going to put volume in yellow. Here's my volume. Okay, so I'm going to plug that in for V, 1,767.1 is equal to 4 pi. I'm going to really bold the R. That's what I'm trying to solve for. Cubed divided by 3. So we had a couple of these in 8-2. You're trying to solve for R. So let's see here. Because this is now algebra, I'm trying to undo everything that's been done to R. I'm going to go ahead and draw my little barrier so I can very clearly see the right side of the equation, the left side of the equation. So I need to undo divided by 3 by timesing. I'm going to go ahead and multiply both sides by 3. Okay. By the way, 10 is a sphere, 11 is a hemisphere. So you really got to pay attention to the difference. All right. So let's see here. 1,767.1 times 3 is 5,301. $5,301.3 is equal to 4 pi R cubed. Okay, right now R cubed is being multiplied by 4 pi. So if you want to multiply 4 times pi so that you can approximate it, you can. You can also go ahead and just divide by 4 pi. You know what, I'm actually not going to do that. You can divide by 4 pi, but you have to put it in parentheses, otherwise your calculator is not going to follow PEMDAS. So, you know, maybe I will show you. Divide by 4 pi, or, in this case, let's see, 4 pi is approximately 12.6, or you could divide by 12.6. Okay, it makes no difference. If you keep it in this format, you have to put the 4 pi in parentheses. Let me show you what I mean. Let's see, I'll put it over on this side. Okay, so 5,301.3, 5,301.3 divided by, in the denominator, you got to use parentheses. Parentheses 4 pi, close parentheses, enter. 421, let's call it 421.9. I'm just going to write it over here. $421.9 is equal to radius cubed. Let's try that. If I leave it as 12.6, I should get about the same. Okay, so again, one more time, I'm going to divide 5,301 divided by 12.6. Okay, so 420.7, that's pretty close. That's close enough. So either one of those will work. Just remember, if you're going this route, you have to put this in parentheses. Otherwise, the calculator isn't going to follow PEMDAS. Okay, so now here's the deal, is we don't want to know what r cubed equals. We want to know what r equals. We want to know what the radius is. So how do you undo something that's been cubed? You take the cube root. Okay, so you're going to take the cube root of both sides. And let me remind you how to do cube root. Okay, clear. To the power of button, right? So second function, I think you hit 3 first, second function to the power of, and I'm calling it 421.9. And I'm landing on about 7.5. Let's call that 7.5. So that is telling me that the radius is about 7.5. By the way, 7.5 meters, not meters cubed, because remember, radius is just one dimension. Okay, and just as a reminder for this, because I know it's been a while, second function, actually, sorry, I'm going to back up. Got to hit the 3 first, then second function, and then to the power of button. Oops. And then go ahead and enter the number inside of the radical symbol. In this case, 421.9. Okay. 11 is going to be similar. The difference is that it's a hemisphere. So you have actually one extra step to undo. So let's just plug it in here. This is the work for 11. 2,712.3 is equal to 4 pi r cubed divided by 3 last time, just like last time, now also divided by 2. So you're going to multiply both sides by 2, you're going to multiply both sides by 3, or you can combine and multiply both sides by 6. But you're having to basically, there's an extra division step here, okay? All right, just a little bit of help set up for 12. This is a compound solid, so you have a cylinder here. Pi, volume is equal to pi times radius squared times height. And the hemisphere for pi r cubed divided by 3 divided by 2. You're going to add those two up. Okay, I think that's pretty much it. There's one in the spiral review that I guarantee is going to be tricky. Let's see here. So by the way, for 30 through 35, they're asking you to find the circumference and the area. Just as a review, circumference is equal to pi times diameter. Area is equal to pi times radius squared. Okay, so they're actually two different answers for each. Pay attention to the difference between diameter and radius. You're going to need both. Okay, so to get radius, you're going to cut diameter in half. If they're giving you radius, you're going to multiply it by 2 to get diameter. All right, since you're going back and forth between two formulas, you do need both. Okay, the very last one we will talk about for the year, I promise. I'm done torturing you guys. 36 says a conical icicle has a volume of about 12 inches. If the icicle has a height of 8 inches, what is the diameter of the icicle? Okay, so this is 8th grade standard. This actually comes from 8-2. We just did this. Conical, it's a cone, volume of a cone. So volume of a cone is equal to pi times radius squared times height divided by 3. Remember, because 3 of them fit into a cylinder, a corresponding cylinder. A congruent cylinder. Okay, so I went ahead and I plugged in what I knew. I know the volume is 12. I know the height is 8. Basically, I'm trying to solve for the radius. Okay, so just like last time, you're trying to undo everything that's been done to the unknown variable. In this case, it's r. Go ahead and, this is algebra. Draw your barrier. You're going to undo divided by 3 by multiplying. So 36, 12 times 3 is 36, is equal to pi r squared times 8. Okay, well, pi times 8, I'm going to do the opposite and I'm going to divide. Again, you can divide by 8 pi in parentheses, or let me give you the approximation. 8 pi 25.1. Okay, either way, you're 36 divided by 8 pi or 36 divided by about 25.1, you'll get something pretty similar. Okay, 36 divided by parentheses 8 pi, close parentheses, 1.4. 1.4. This all cancels out. I'm left with r squared. How do you undo something that's been squared? Take the square root. Okay, so the square root of 1.4 is approximately r. All right, guys. It's been interesting this last couple of months. I appreciate you sticking with it and attending Zoom meetings and watching the videos. Obviously, it's not ideal, but, you know, we all did the best we could. So, at any rate, I miss you guys. I hope to see you around. You're certainly better students than Sweet Pea. She doesn't even pretend to pay attention. At any rate, hope you guys had a good year, and if you have any questions, I will see you on Thursday at 11 o'clock. Okay, take care. Bye-bye.